Uh, Welcome to the course on cloud computing. We'll continue our discussion on different aspects of the cloud computing. Today we'll look at or we'll start with cloud computing architecture, right. We'll start with the basic introduction and we'll go to more details in today's or subsequent lectures. So, if we look at this high level architectural approach or high level view of these things. So, what we have at the end of the things what we are looking for, one is that from the user perspective or overall cloud computing practices, it is we want to achieve some business goal, right. It can be business goal with respect to consumer, it can be business goal with respect to the producer, or it may be the overall framework of the cloud computing, right. So, some of the business goals is the major thing, which are next we have this quality attributes and then the architectural tactics or the basic architectural framework. So, if you look at that business goal at the top of the things, what we are looking for primarily? We are looking for some TCO, like what is the total cost to the organization, who are the what about the stakeholder satisfaction, compliance with different standards, market share, flexibility, etc. So, this is the overall business goal from the CSP point of view, and to achieve this business goal, we have few more parameters which need to be looked into or which need to be monitored, measured, and what we mean to say that need to be managed properly is that issue of availability, elasticity, interoperability, security, adaptability, performance, usability and maintainability. Now, if you look at this, if you just go back in 1 or 2 lectures when we started with the basic definition of cloud computing. So, we were looking for these aspects of the things, like that whether how much available, how it is elastic, how what are interoperability. So, these are major what we say major characteristics of the cloud. So, this characteristics basically allows a service provider to define his business goal across this different cloud market. And finally, in order to achieve this different measured services or the business goals, we need to have basic architectural tactics or architectural view. So, like the considerations are whether it is a stateless design, whether we are loosely coupled, right. What we are thinking that there are several devices which are geographical spread. So, they may be loosely coupled, heterogeneous, need to be what we want to bring into the thing is some sort of a interconnect and homogeneity between the things over broad network access, right. So, what is the caching mechanism? So, claim what should be the authentication, whether it is a claim based authentication, then there are several other aspects of this architectural tactics. Now, if you look at this sort of things, somewhere or other are manifested at any type of service model. Like if I say infrastructure service model, so some aspects will come into play. If I say PaaS, some other aspects will come into play, and we have SaaS or any other type of model. So, this becomes important, keep in mind while developing, proposing any architectural view. So, with this respect or with keeping this in view, we will see that what are the basic consideration to have this cloud architecture. So, if you look at the major building block of cloud computing architecture, one is that technical architecture, right, structuring according to the XaaS stack, right, adopting cloud computing paradigm, structuring cloud services and components, middleware and communication and manageability and security. So, these are more technically technical feature of the architectural things. There are some of the things which are deployment operation architecture, right, like geolocation check, right. I may want to say that due to my federal requirement, all my data, all my applications for my any type of government related activities should be within the territory of the country, right. I do not host or any application or any data outside the things. like if I am having a mail service, the mail data, mail server etcetera should reside within the geographically bounded area of the of our nation. So, that may be a things. There may be a lot of other legal issues etcetera, and there are deployment issues like operation and monitoring. So, what should be the operational view, how it will be monitored, how this SLA etcetera to be looked into, those are the other deployment operation architecture. So, if you look at this typical XaaS thing, so what we have at the down is this infrastructure as a service, then platform as a service, software as a service. This is the typical stack of the or typical or most popular XaaS applications or services. Now, if you look at the this architectural side of the things or the basic building blocks. So, down the line is more of a storage and infrastructure. So, this is that is the colored in the blue, up in the thing is the applications, right, and there are the client infrastructure which interacts with this application. In between is the middleware, or what we say that the platform or the platform as a service type of things, where the services, cloud runtime, libraries and other things come up. So, any realization of any cloud computing in infrastructure, whether it is a public, private, open source, customized, we need to look into some way or other. This broadly has to have this type of realization. And if we look as view of that consumer versus providers or the customer versus provider. So, there are again for the IaaS, this is primarily important for IT architect in the IT operation type of things. For the end user or the application user, that is more important is the application administrator etcetera, which hovers around the top of the things, like one of the popular applications may be the CRM, right. And whereas, for the software architect or the developer, which comes in the middle, which uses this hardware infrastructure or which uses this infrastructure as a service, develop something and which are deployed or put support to this application above this. So, these are these categories like in the middle of the things. So, different people or different category of users have different view of this architecture, right. Now, we just try to map that with this our very two popular two popular cloud services. There are several other popular services, but these are the things which are available on the which we could get. So, one is the Microsoft Windows Azure platform, another is the Amazon cloud platform or Amazon EC2. Now, look at that also divided into more or less in the that 3 stack, right. This is as more at the bottom of the things, same as the in case of the EC2. In case of Amazon, it is Windows servers and related stuff, whereas in case of EC2, it can be Windows Linux infrastructure along with S3, Amazon S3 and simple DB and other type of storage, and in between it we are having this this middleware or the which emulates that platform. This has a analogous stuff here, and at the top it has the applications, right. These are some of the Windows Azure applications and these are the Amazon's applications, and here the client can connect through either in case of a client this is Silverlight in case of this, or we can connect it to the browser. So, one thing I just like to mention, it was there in the previous slide also, there are 2 vertical stack, right, what we say management and security, right. This is important because this management and security issues, sometimes people want to put that security is also a management aspect, and sometimes we have other aspects like what we say quality of services. So, management, quality of services and security in some of the references or materials you will find that. So, these are the scenarios where these are the stack which goes vertical. That means, it cannot be I cannot achieve security or management taking only one layer at a thing. So, it requires some sort of a cross layer considerations. That is why these are vertical stack. And if you see the same thing in case of this Azure or EC2. So, these are also we have these vertical stacks, right. So, they have different component of security, different component of management, but this goes on the vertical stack. Similarly, the security aspects based on the we will see later on, based on how much control we are having goes on to the things. Like if I am having infrastructure as a service, so my security or management is more consideration on the as a infrastructure. So, once I roll out this infrastructure, one I provision this infrastructure, the virtual machine, etc. So, that is the responsibility of the user or the consumer to look into the things. If I having a up to a software as a service, then all these issues are need to be provided up to that layer, right. So, say a word processing service or CRM service, which is as a software as a service. So, all aspects up to that level of management and security need to be provided. So, that it depends that what sort of service provisioning or the what sort of service deployment we are doing for this particular scenarios. There are several aspects or issues as we are talking about. One is that elasticity, as we have mentioned or as we know that elasticity is one of the most important characteristics of cloud. Like if I can scale up, scale down into my into this computing paradigm. Now, in order to achieve that, so there can be two broad approaches, right. So, this is these two broad approaches which is true even without cloud also, it is more of a elastic computing window. One is that I can do a vertical scale up, that means add more resources to the box, right. We have a particular infrastructure, say for example, I have a particular rack with different servers. So, initially we are having, say I am having some 24 servers, then I scale up putting more server into the things, or my chassis may be holding 16 blades, I am having initially 4 based on the requirement. The organization feels that the requirement go or another 4 or go up to a 16 blade chassis, like fully loaded chassis. Now, this is vertically going up, right. So, this is has advantage where for in case of a small scenario, scale up is probably cheaper, so that it works just you just put on the things, right. So, add more resources to a single computational box, move workload to the computational unit to more resources. So, I have more resources, whereas when we have scenarios where for larger scenarios scale out is only solution, 1:64 way server is much more expensive than 64 into 1 way server, right. So, having say 64 of 1 unit computational power and trying to realize a 64 computational units is much cheaper than having a 1 unit of 64 computational. So, what is happening that when I have a large scale scenario, then expanding in that fashion may be pretty costly. So, in that cases not only expanding in terms of cost, in terms of only financial aspects, it is maintainability, rate of failure may be pretty high, like if a single system, it is a single point of failure at times, whereas if I have a multiple system, so that if some system fails, then I can have a way to work on in a little lower performance metric, but I can work on the things. So, this becomes that whether it is a horizontal scale up or scale out or it is a vertical scale up, we need to consider based on our requirement. Now, if we again come back to our service model. So, XaaS, what is happening is a combination of a service oriented infrastructure or a service oriented architecture for realization of infrastructure and cloud computing realized to XaaS. So, what is the service oriented architecture? I believe most of you are already knowing. So, what we will do we will have a some few slides on service oriented architecture in subsequent lectures, so that those who are not in the not accustomed or not very much familiar with this type of things, we will have a immediately quick checkup. But nevertheless, it is a service driven approach for infrastructure or PaaS or any type of things, right. So, we try to combine SOI and cloud computing to realize this XaaS. So, anything as a service is a generalization of cloud related services, refers to an increasing number of services that they were delivered over internet rather than provided locally or on site. XaaS is the essence of cloud computing, already we know. So, anything as a service. So, 3 we seen, data as a service is another popular, we can have anything other type of services, right. So, as some of these popular XaaS instances, one is infrastructure as a service, platform, software as a service already known. There is another thing came up, what is now becoming pretty popular, what we say business process as a service, right. So, or I have a business workflow which I want to give as a service. So, horizontal or vertical business processes provided on a subscription basis to companies or industries. Like suppose for a particular operations, I have a business process, right. So, what that is does it mean? It may not be only one applications which is delivering the things. So, I have different processes which has a orchestration between them and then allow me to realize a particular applications, right. It can be for something for the banking sector, it can be for some of the aspects of different development planning operations of the things. So, it is not only I run a application and get results, a application is dependent on other applications and other etcetera, etcetera. So, I have different processes or applications which allows me to realize the thing. So, it means as if P12 may lead to something called P3 which can is a input to the P3, and in turn P3 and P4 will come out of the final outcome of the things. Now, I have different maybe different processes, right, or so these are the orchestration in the things. So, I can say that I have a business process which is basically division of the or amalgamation or integration of the different sub processes or sub applications. The interesting feature is that there is a timing relationship and a what we say process execution tree or process execution graph will be there. So, that it follows a particular things. Now, for this sort of things, if it is a defined, then whether I can say this I give a service with a business process thing. So, it is not only application as a service or software as a service. So, I basically have a something more than software as a service which talks with things. Incidentally, these different processes may come from different heterogeneous providers. So, I can basically now interact with or collaborate with different cloud service providers and then realize a thing. So, this business process is important because end of the day, especially for the organization, this matters. Rather many of you might have heard there is a very popular language what we say business process execution language, where you can define your this business process or workflow into the things and so it realize the things, right. So, that is one of the major aspects. So, IaaS is the raw infrastructure, CPU etcetera. PaaS is the virtualized application development or runtime platform. SaaS is the software application hosted in the cloud provider in the subscription basis, and this business process as a service is the horizontal or vertical business process involved in the basis on a subscription basis to the companies or industries, right. And if we again little relook, so it is something a tapering thing for our popular IaaS, PaaS and thing, PaaS other infrastructure. So, other than these three most popular examples, we have several other business process, several other XaaS instances, like we have already seen business process as a service, there is storage as a service, I can have security as a service. right, is it provides different security feature as a thing. I can have database as a service, right. So, I do not want to install etcetera. I want to leverage a database into a service. Monitoring management as a service, like I want to manage my IT infrastructure, like I have a large, say in our IIT infrastructure we have large labs which are used by different category, different type of PG, UG courses, and I want to basically manage the things, right, like manage the things starting from software of the means what are the software going on, whether the machine is basically having any problem from the hardware or type of things, different things. So, whether I have separate tools or somebody gives me a service which connects with these machines and do the things, right, or any large infrastructure for in case of a organization. So, communication, content, computing as a service, these are the some of the things, identity as a service, backup as a service, desktops as a service. So, I can have anything as a service, and these are some of the things which are being used across the world. So, end of the day what the CSP or the cloud provider is looking for, increase productivity, end user satisfaction, some innovative services, so that it can hold its market position and have different increase, its infrastructure is agile, right. So, it is agile and it can give, it can what we say configure itself along with the need of the requirement. So, if we look at this again, if we come back to our basic definition and try to see. So, one is the broad network access, resource pooling, business driven infrastructure on demand like what is there, and service oriented architecture. So, all these four helps us in realizing this XaaS type of services. So, XaaS fulfills all the four typical demands of service provider. Now, like our network stack, like our TCP IP or OSI models. So, if I want to have that, what will be the typical classical stack of the things, right, stack of our service model or XaaS model. So, at the base of the things what, so it is not like that, so it is a what we say logical way of looking at the things, right. It is not like that something will run always over the other, but it is a logical representation of the things. Like at the core of the thing is the networking. So, you have a underlining broad network access which allows the things to talk to each other, right. Another core component is the storage, right. It is also something omnipresent. Other aspects is the server. So, if you look at these three stuff are primarily is the major building block, what we say the bare metal things over which it works. So, one is the communication, one is this different servers and other physical infrastructure, and other one is the storage. Storage always we try to keep it in a separate aspects other than keeping one of the infrastructure. In some of the cases storage are kept as infrastructure, but storage plays a different type of role. Storage management is different thing. So, those are important aspects of the storage is important aspects. Over that, what in order to realize other things is that is aspect of virtualization, right. So, I need to virtualize all the things. So, I can have a virtualization of the whole infrastructure, I can have virtualization only of the particular VM, a virtual machine, I can even virtualize the network. So, I have a network infrastructure, I want to realize a particular virtualized network infrastructure, and of course, storage. So, that is a virtualization basically try to have this so called virtual machines or virtual networks, virtual storage type of stuff. Over that, if it is a virtual machine, I need to put the particular OS over which I should run the things, right, or and so this over that this middleware, then I have runtime library, the data over for which more closely with the application, and finally, end of the top of the stack is the applications. So, these are the different components which makes this IaaS at the feasible. It may be noted that all the components are not equally important, may not be equally important for all type of XaaS type of things, but nevertheless, they play a important role in realization of the thing. Now, if we try to, because always it hovers that all we are somewhere or other we are already getting these stuffs, right. What is this big paradigm shift, right. So, as such we should we have already mentioned in our initial lectures that already we are having distributed systems and other things into place. We do realize lot of the things, etc. So, make it more market viable and having a scalable computing infrastructure, pay as you go model, measured services, we are realizing it. So, if you look at that a simplified IT stack, so we have end user devices, application and dedicated infrastructure. So, this is in the legacy IT, or still it is very much present in, or rather omnipresent in various organizations and other type of things. So, these are somewhat clipped together, right, or more strongly coupled, right. So, that dedicated application runs over the applications dedicated infrastructure. So, application sizing, etc., are made based on the infrastructure or other way around. End user also have some dedicated application to work with, right. Whereas, what we go for, what we are trying to realize is more of a simplified IT infrastructure, right, where these are little bit flexibilities are maintained. So, I have some dedicated infrastructure or application and end user devices, but they are not very strongly bound. So, this is the thing what we are going to do, and it can be shown also. We will see in some of the subsequent lecture that this sort of things may allow us to have better utilization of the resources or better return on investment, right, or giving service different type of services on the same type of or a common resource based type of things. In some of the cases, several organization has several surplus resources, like if I talk again about our own UG or PG labs, which may be having huge amount of computing resources, but they may not be utilized across 24 hours, right. They are utilized maybe 8 to 10 hours on a very loaded, but out of class hours or out of lab hours, those can be clubbed together to give the researchers a opportunity to run high simulation on the basic PC type of platform. So, that may be one way of utilizing own resources in a better fashion. So, there are some of the other things like classical model plus XAS model. There are different aspects like license software, hardware product and people based services. These are the more popular aspects of our traditional cloud, traditional infrastructure models or classical infrastructure model, and we need to make the architecture in such a fashion that it maximizes this effort. Whereas, in our emerging things, we have gone to a XAS type of services, like so that is software, IaaS, PaaS or any type of XAS type of services. And rather, if you look at our classical things, or still it is very much valid, we have a client server architecture, right. So, there is a server which serves several clients, and based on the server program is running on the server and always waiting for the client to connect, and we connect to the things, and this is extremely popular and still very much in the use and will be in the use in several cases, right. But from there we have migrated to a service oriented architecture. So, instead of this very strongly coupled client server, we have service oriented. So, service talks to each other, and there are distinct advantages. We can have heterogeneous things to talk to each other, and we have lot of flexibilities. Very popular client server things are like FTP server, Telnet, HTTP, where you have a particular daemon or the server part which looks into this, talks to this client. So, we will carry on our discussion in our subsequent lectures on these particular architectural aspects of cloud computing, and we will also see that different things of virtualization and other things. So, for today we will for now, for this lecture we will stop here. Thank you.